Okay, today we're looking at the notes on direct variation. So, when we hear the word direct variation, okay, this phrasing right here, okay, it means two quantities are connected by a constant multiplier. Mathematically, that means y equals kx, or another way to think of this is y equals mx. And remember, m in this case is slope. They use the term k for this idea of the constant of variation or proportionality. Okay, but again, it's affecting it just like slope affects it. But if you notice, it's missing something. There is no b. Remember, slope-intercept form is y equals mx plus b. There is no b value. So what's going to happen is it's going to go through the point 0, 0 every single time. And it's going to be affected through multiplication every single time. So what this also looks like, you'll often see the phrasing of y varies directly with x, or y is directly proportional to x. What you'll often see also is instead of using y and x, it will say something along the lines of the terms, like h varies directly with c or something like that. It still means the same thing. Something is multiplying. Something is multiplying this. I've got an L in there. Okay. Multiplying this to get you this. So step one, y varies directly with x. So that means y equals kx, some number times x. Okay. The constant of variation, okay, they'll give you some values x and y to solve for k, and then you substitute k in for this. So it'll say something along the lines of this. If y equals 4 when x is 12, then find k and write the equation. So what this is saying is we have this point, 12, 4, right? Just like your normal xy, okay? And it wants to know what we would have to multiply this 4 by, or this 12 by, in order to get this 4, okay? So again, y equals kx. My y value is 4. I don't know what k is, and my x value is 12. So what's the opposite of multiplying here? Is dividing. And 4 divided by 12 is 1/3. So my k value, or my equation, is y equals 1/3 x. Again, it's still multiplying here. It's just happening to multiply by 1/3, which is perfectly fine. That's just a decimal. Okay. In these questions, it's going to be phrased it'll be consistently phrased very similarly. Oh, similarly, if I can speak today. The value of y varies directly with x. Again, there's something that is multiplying x that will get you y. When the value of x is 32, the value of y is 80. What is the constant variation? Okay, so for your first point, we have our x value of 32, our y value of 80. So another way to look at this, I purposely did this like this. Another way to look at this is I'm going to have something, this k value, multiplying this x, and it's going to give me this y. Okay, and remember, this k, I don't know yet. It's a question mark. It's going to multiply 32 to get me 80. So how do I figure out what times 32 gets me 80? Well, I take 80 divided by 32, and in this case, that is 2.5. So my constant variation, 2.5. Write my equation, y equals 2.5x. What is the value of x when y is 100? So when y is 100, so I would have 100 equals 2.5x. So I take 100 and divide it by 2.5, which happens to be 40. Number 2, the value of y is directly proportional to the value of x. Again, they use some different wording here, varies directly and is directly proportional. It still means the same thing, okay? You can still set up a table. Again, I don't know what k is, but it's going to multiply x, and it's going to give me y. My x value is 3. My y value is 21. So when x is 3, what would I have to multiply 3 by in order to get 21? Well, 21 divided by 3, that's 7. So my k value is 7. That's my constant of variation. The number I would need to multiply by in order to get to satisfy this. Write the equation, y equals 7x. What's the value of y when x is negative 18? So y equals 7 times negative 18. 7 times 10 is 70. 8 times 7 is 56. 70 plus 56 is 126. So y equals negative 126. Double check me, use Desmos, make sure that I'm correct. I'm human, I make mistakes. Number 3, the cost of buying movie tickets varies directly with the number of tickets purchased. This makes total sense, right? The cost of buying the movie tickets depends on how many tickets you purchase. If you buy more tickets, it's going to cost more money. Okay. And it would be proportional too. Okay. It would be proportional because it's not like two people pay something and a third person pays something else. That doesn't make any sense. Okay. It's saying everybody's paying the same amount. We bought 3 tickets and it cost $27. How much would it cost for 5 tickets? Okay. Now, here's the other thing that I brought up at the beginning and haven't addressed. Ready? How much would it cost if you had 0 tickets? Well, if you had 0 tickets, that would cost $0, right? Well, if that's the case, couldn't we put that table in Desmos? And unfortunately, you can't see Desmos right now on my screen, but you could type in a table, an XY table, I don't know, 0, 0, and then 327, and then do a linear regression and figure out that y equals 9x plus 0, which makes sense because it doesn't cost anything for 0 people. 3 times 9 is 27. That makes sense. So how much is it going to cost for 5 people? Well, y equals 9x. Y equals 9 times 5. And 9 times 5 is 45. The cost per ticket? 9. That's my constant of variation. How much does it cost for 5 people? It costs $45. Oh, wait, not 45. No, no, no. That's 9. Yep, that's correct. Never mind. I just noticed that the key was wrong. Number 4. The force in newtons needed to lift an object is directly proportional to its weight in kilograms. It takes 50 newtons to lift a 10 kilogram object. A force of 80 newtons is applied. What is the weight of the object being lifted? Again, we can use a table. Again, we know the force in newtons lifted to lift an object, so newtons is going to be my y value. The kilograms is going to be my x value. So 10 kilograms, 50 newtons. I want to figure out what it takes to do 80 newtons. And remember, if I don't have any weight, I didn't use any newtons. So again, I can build my table in Desmos, 0, 0, 10, 80. and or 1050, excuse me, 1050. My regression is y equals kx. In this case, or again, the regression will give it to you like this, right? Y equals mx plus b. In this case, your m value is 5. Your b value is 0, which makes sense. Again, this is proportional, so it needs to go through the origin. Okay? So therefore, 5 is my constant of proportionality. If it required 80 newtons, and I use 5 newtons per, 80 divided by 5 is 16. So it would be a 16 kilogram object using 80 newtons. And again, my constant variation is 5. So again, relating this back to a similar concept, 5 is our slope. The origin is always our starting place, because if these things ever zero out, you're not lifting something, you're not buying tickets. Okay, it's 0, 0. So you can use a table to do a regression to figure out what your constant variation is, which again is your slope. And then you can also input these values to try and figure out, is it going to be your x value, which in this case is 16, or is it going to be your y value, which in this case you would multiply and get 45. So that's how direct variation works. Again, you can use a table or you can solve it by hand.